On today's episode of All About Libs, we're going to take a look at two low alloy steels. These are chrome-moly steels. They have excellent weldability. They're resistant to oxidation and scaling. So without further ado, let's get right into it. Okay, so first let's talk about the general characteristics of these two grades. They are both chrome-moly steels, and they have common names, being 1 1/4 chrome, half moly for the F11. That stands for 1.25% chromium in the actual material approximately, and about 0.5% molybdenum in this material. And similarly, F22 is 2 1/4 chrome and 1 moly, so you have slightly more alloying elements with F22. You have slightly higher strength and slightly higher corrosion resistance. So they're both extremely weldable. Makes them favorable materials to pick during material selection. And they're so weldable, in fact, that you can put overlays on top of them. Nickel-based materials for power generation and other exotic applications. They're resistant to scaling and oxidation, and that is at temperature range as well, between negative 20 degrees Fahrenheit and all the way up to 1100 degrees Fahrenheit. Now, keep in mind that in order for these to be oxidation resistant, they are resistant, they're not proof, and you need to have a non-corrosive media. So they can hold oil, gas, and water as long as those materials are non-corrosive and relatively inert. They are both hardenable by heat treatment, and they are pretty strong and tough. The applications include piping. A lot of piping assemblies, you might see these in pressure vessels and pump and valve components. But let's take a closer look at the chemistry, starting with F11. Okay, so first up here, we've got F11. We'll do F22 in a moment. Now, F11 is typically called F11 Class 2. The cast grade for this is WC6. It's also typically referred to as 1 1/4 chrome and half moly. So you can see that's written right on this sample. It can be used up to 593 degrees Celsius or 1100 degrees Fahrenheit, and has a tensile strength of about 70 KSI. So let's take a closer look and see what this looks like. We're going to approach that with the analyzer, and we'll do a test here. Okay, so now as you can see here, that name 1 1/4 chrome and half moly, you can see we're right at about those levels. There's a little bit extra manganese in here, but it's mostly iron. And it's a pretty alloy. You can see up here in the upper right hand corner, first of all, we call this 1 1/4 chrome at Rigaku, and then up here in the upper right hand corner, we have this 100% match. So you can see it's easily sortable with handheld LIBS, and we use this 1 1/4 chrome name because we can see both the forged grades and the cast specs in the field. Okay, so next up is F22. Now this grade, F22, is the forged grade. It's typically called WC9 if it's cast, and this one is a little bit different. It's 2 1/4 chrome and 1% moly. Now these are both low alloy steels, and this can be used under the same temperature range as F11. It also is slightly stronger at 75 KSI for its tensile strength. Okay, so as you can see, it's pretty easy to see that we call it 2 1/4 chrome, the common name. And up here, we've got 100% match, so it's easy to see with handheld LIBS. The iron is the primary, is the base element in the material. The chrome here is about 2.4, so pretty high. The manganese, or the moly, excuse me, is right about 1%. So that's where you get that common name. The manganese is about 0.5%, and there's some other contaminant elements in it as well, but it's primarily just a low alloy steel. Thanks for tuning in this episode about F11 and F22. I hope you learned something about each of these grades, as they're very common. I also hope that you could see that they're very easily sortable with handheld LIBS. If you have any questions for me, please comment down below. Please like this video if you've learned something, and please subscribe to my channel if you find my content valuable. Thanks again for tuning in, and we'll see you real soon.